Welcome to Meki Techie. Let's learn as engineer, teach as a champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in the public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting a spark to creating technical videos in the public domain. And I would like to thank Almighty, my friends, followers, and my students, and my subscribers. Today's topic of interest is screw jack. Okay, let you give a beautiful example about the screw jack. If we have a heavy vehicle, one of the day, if our vehicle is got punctured, either a front wheel or a back wheel, what we have to do, we have a jack is there. We put a jack on the rigid rod and we rotate the tommy bar and the jack screw, and we get an increase in the length to remove the tire. There, that is the application of the screw jack. We want to lift a heavy load with minimum amount of effort. There, we can use screw jack. Why it is called as a screw jack? There, screw threads are used. Square threads, mostly the square threads are used in the screw jack. That is why it is called as a screw jack. Name itself, we can say there is a screw. In jack, there is a screw. That is called as a screw jack. If there is a, instead of screw, if there is a hydraulic or pneumatic, we can say it as a hydraulic jack or a pneumatic jack. Okay, so therefore the base is the screw jack. In the designing of screw jack, we consider the screw jack as a vertical column where the condition is one end is fixed and the other end is free. Okay, so that is the application, or that is the way of designing a screw jack. One end is fixed and other end is free. Therefore, the screw jacks are failed by means of a buckling load. This we have to understand. And when the motion of the screw jack, there is a two kinds of angles are available. One is the helix angle and another one is the friction angle. Okay, let me discuss in detail about this screw jack. In the screw jack, the square threads are used. Most of the conditions, the square threads are used. What is the advantage of the square thread is the helix angle is 0. When the helix angle is 0, the effort required to lift or lower the load becomes minimum. Therefore, we have to know what is the effort required to lift or raise the load. That is, PR is equal to W tan pi minus alpha. So here pi is the friction angle and alpha is the helix angle, where W is the load to be lifted and P is the effort required. When the effort required to lower the load, it is very simple. Instead of plus here, we put a minus. We can get for lowering the load. That is, P is equal to W tan pi minus alpha. Here, two conditions we have to know that when the screw are called as a self-locking or an overhauling, the condition is when the friction angle is more than helix angle. When friction angle is more than helix angle, it is said to be self-locking. The efficiency of the self-locking screw is always less than 50%. When it is an overhauling, 50% here, okay. When it is overhauling, the friction angle is less than helix angle. The friction angle is less than helix angle, and also the efficiency is more than 50%. Sorry, I'm making a mistake. This symbol, okay. less than 50%, more than 50%. Okay. If the efficiency is more than 50%, it is said to be an overhauling screw. When the efficiency is less than 50%, it is called as a self-locking screw. Okay, the formula for finding the efficiency of the screw jack. We know that the efficiency of the screw jack is depends upon the friction angle and helix angle, and here the efficiency of the screw jack neta is equal to tan alpha divided by tan pi plus alpha. Always you have to know that in any formula of finding an efficiency, the denominator is more than numerator. Okay, that is why here it is plus positive symbol. Okay, here it is positive symbol. If the denominator is lower than, if d is lower than n, then efficiency will be more than 100%. Efficiency is more than 100%. So this is, that should not be happen, or that is not happen in any of the machines. Always the output is less than input. Okay, so that is the natural law that you have to understand for finding an efficiency formula. Here there is a condition for the maximum efficiency. For the maximum efficiency, alpha is equal to 45 minus pi by 2. That is, alpha is the helix angle. Helix angle is equal to 45 minus friction angle by 2. There, if we substitute instead of alpha the 45 minus pi by 2, the formula becomes neta efficiency is equal to 1 minus sin pi divided by 1 plus sin pi. And the maximum efficiency depends on the friction angle pi, or a coefficient of friction. So this you have to understand. Depends upon only upon the friction angle, not for the helix angle. Okay. Next one, we have to know what is meant by a friction angle. It is an angle between the resultant force and the friction force, that is called as a friction angle, and coefficient of friction is the normal limiting friction to the normal friction. The ratio of limiting friction to the normal friction is called as a coefficient of friction. Okay, here you have a very good example where the efficiency of the screw jack is less than or equal to 50%, it is called as a self-locking, and it is an irreversible machine. When the machine is said to be a reversible, there the efficiency is more than 50%, that is an overhauling screw. Next, in the screw jack, we already said that we are having square threads, therefore the helix angle is 0. For the different kinds of threads are given here, and their respective helix angle are also provided here. When there is an ACME thread or an ACME thread, that is 29 degrees, and buttress thread it is 45 degree, and British Association thread BAT, that is 47.5 degree. British Whitworth thread is 55 degree, and square thread is 0 degree. American thread is 60 degree, and unified thread is 60 degree. Okay, and in some of the cases we are using multi-start thread. For your better understanding, in all your water bottles or a water cans or a soft drink cans, they are using a multi-start thread. You can easily notice that. What is the purpose of multi-start thread? Is the multi-start thread is having more efficiency. It is having more efficiency, and I'm going to give certain highlights for ACME thread, buttress thread, and square thread. First, ACME thread is used in move in both directions. Acme thread can use it to move a component in both directions. That is why in the lathe screw threads where the carriage is moving, there we are using acme thread. In the buttress thread, it is moving in only one direction only. It is in the form of, mostly the buttress thread is in the form of trapezoidal shape. Uh, Therefore, it can be used in tight leak joints as well as the railway garage couplings are using buttress threads where the square thread nuts are made of a soft material, and square thread is assumed to be a column condition. The design purpose, it is assumed to be in a column condition, that is one end is fixed and another end is free. And the screw jack is independent of load. We are not taking care of a load in terms of finding the efficiency and the power. Here I would like to give a small introduction about limiting friction and kinetic friction. And I will definitely give a brief video about the friction. Here I would like to add a glimpse about limiting friction and kinetic friction. The limiting friction is the maximum friction. We have three kinds of friction. One is a static, kinetic, and limiting. There, limiting friction is a maximum friction that is possible in a body. Where it comes, the limiting friction which comes into play as the sliding motion of a body is just to begin. When the body is just to begin to slide, that point in time we get an limiting friction. In the kinetic friction, when the body is continuously experiencing in the body, friction experiencing in the body is in continuous motion. There, kinetic friction or dynamic friction is there. Therefore, we have to notice that the intensity of limiting friction is more than static friction. It is more than dynamic or a kinetic friction. And the small point, you have to notice that, or you have to remember that in the screw jack is a self-locking device. Screw jack is a self-locking device and reversible machine, sorry, irreversible machine. Screw jack is a self-locking device and a irreversible machine. If a screw jack is said to be a overhauling device, then it is a reversible machine. So with this understanding, I would like to close my video. So if you have any doubts, you can let me comment in the comment section. I will put, or I will clarify your doubts. Thank you once again. I hope that you have all enjoyed the technical session. Thank you all.